Abstract, Industry 5.0 represents a paradigm shift from automation-centric manufacturing toward human-centric. Sustainable and resilient production systems that harmonize advanced technologies with human creativity and values. This transition demands a fundamentally different leadership archetype, one characterized by polymathic thinking that bridges technical, humanistic, and systems-oriented knowledge domains. Polymathic leaders possess exceptional capacity to learn across disciplines, connect disparate knowledge fields, and integrate insights from technology, psychology, ethics, sustainability, and organizational design into coherent strategic frameworks. Drawing on research from organizational behavior, neuroscience, innovation studies, and industrial transformation literature. This article examines why polymathic leadership has become essential for navigating Industry 5.0's complexity. It explores evidence-based approaches organizations can implement to cultivate polymathic capabilities, presents examples of polymathic leadership in practice across manufacturing, healthcare, and technology sectors, and outlines frameworks for building long-term organizational capacity for interdisciplinary thinking and adaptive problem-solving in an era defined by convergence. The industrial landscape stands at an inflection point. While Industry 4.0 brought unprecedented automation, data exchange, and cyber-physical integration, Industry 5.0 introduces a fundamentally different value proposition, restoring human agency to production systems while pursuing sustainability and resilience as core objectives rather than afterthoughts. Breck et al. 2021. This transition is not merely technological, it represents a philosophical reorientation toward production systems that enhance rather than replace human capability, that regenerate rather than deplete natural systems, and that distribute rather than concentrate economic value. Such multidimensional transformation cannot be led by specialists, however deep their expertise. The convergence of artificial intelligence, biotechnology, materials science, circular economy principles, and human-centered design creates challenges that defy traditional disciplinary boundaries. Leaders must simultaneously understand algorithmic decision-making and workplace psychology, materials engineering and ecological systems, financial modeling, and ethical frameworks. They must translate between the languages of data scientists and frontline workers, between sustainability metrics and shareholder value, between technological possibility and human flourishing. This is the domain of polymathic leadership, an approach characterized by breadth across multiple knowledge fields, depth in integrating diverse concepts, and the cognitive flexibility to navigate ambiguity and complexity. Research in organizational cognition suggests that leaders with broader knowledge networks and varied expertise make more creative strategic decisions and navigate uncertainty more effectively than narrow specialists. Dane. 2010. Neuroscience research indicates that creative thinking patterns, characterized by diverse knowledge acquisition and heightened pattern recognition across domains, enable unique insights by connecting seemingly unrelated concepts. Kaufman. 2013. The stakes are considerable. Organizations pursuing Industry 5.0 transformation face investment decisions involving technologies still emerging from research laboratories, workforce transitions affecting millions of employees, sustainability commitments requiring systemic redesign, and ethical dilemmas without established precedents. Leadership failures in this context risk not only competitive disadvantage but societal harm, from algorithmic bias at scale to environmental degradation to workforce displacement without adequate transition support. This article examines polymathic leadership as both cognitive capability and organizational imperative for Industry 5.0. It synthesizes evidence on how organizations can cultivate polymathic thinking, presents examples of polymathic leadership approaches across industries, and outlines frameworks for building institutional capacity for interdisciplinary problem-solving in an era defined by convergence and complexity. The Industry 5.0 leadership landscape defining polymathic leadership in industrial contexts. Polymathic leadership extends beyond Renaissance ideals of the well-rounded individual. In contemporary organizational contexts, it represents a specific cognitive and behavioral pattern characterized by several interconnected capabilities. First, polymathic leaders demonstrate active knowledge acquisition across disciplines. They continuously learn in fields outside their primary expertise. From computer science to organizational psychology to sustainability science. Historical analysis of creative achievement suggests that individuals who engage seriously with multiple domains often produce more innovative work than those who remain within single fields. Ruth Bernstein et al. 2008. This learning is not superficial. Polymaths develop sufficient depth to engage meaningfully with specialists and recognize important patterns. Second, polymathic leaders excel at conceptual bridging, identifying analogies, principles, and frameworks that apply across domains. They recognize that manufacturing optimization principles inform healthcare workflow design, that ecological resilience concepts illuminate organizational adaptation, that user interface design principles apply to industrial control systems. This capacity for abstraction and transfer enables creative problem-solving by importing solutions from unexpected domains. Third, polymathic leadership involves integrative synthesis, weaving together insights from multiple fields into coherent strategic frameworks rather than maintaining separate knowledge silos. Boyman-Siller. 2010. Where specialists might propose technical solutions to socio-technical problems or organizational solutions to systemic challenges. Polymathic leaders construct multi-layered interventions that address technical, human, organizational, and ecosystem dimensions simultaneously. Fourth, research on creativity and cognition suggests that diverse knowledge acquisition correlates with enhanced pattern recognition and creative problem-solving capabilities. Carson et al. 2003. While some individuals may possess predispositions toward polymathic thinking, evidence suggests these capabilities can be cultivated through deliberate practice, environmental design, and organizational support systems. In Industry 5.0 contexts specifically, polymathic leadership manifests as the ability to navigate the intersection of advanced technologies, artificial intelligence, robotics, Internet of Things, biotechnology, human factors, worker well-being, skill development, collaborative work design, sustainability imperatives, circular economy, renewable energy, regenerative production, and business model innovation. Leaders must understand not only how these elements function independently but how they interact in complex, often non-linear ways. State of practice, the leadership gap despite the evident need for polymathic capabilities. Most industrial organizations maintain leadership development systems optimized for specialist expertise. Many senior leaders rose through single functional pathways, engineering, finance, operations, or marketing, with limited cross-functional experience before reaching senior roles. Educational systems reinforce this pattern. Advanced technical degrees emphasize depth over breadth, while business education often lacks substantive technical and scientific content. The consequences become visible in Industry 5.0 transformation initiatives. Organizations frequently fragment integrated challenges into separate work streams, a technology team implementing AI systems, an HR team managing workforce implications, a sustainability team addressing environmental impacts, without adequate cross-functional integration. This structural separation reflects and reinforces leadership cognitive patterns that compartmentalize rather than synthesize. Several factors perpetuate this gap. First, traditional career advancement systems reward specialized expertise. Engineers advance by becoming better engineers, financial analysts by mastering increasingly sophisticated modeling techniques. Lateral moves into unfamiliar domains often appear as career detours rather than developmental investments. Second, time poverty at senior levels creates pressure to rely on existing expertise rather than invest in learning new fields. Third, organizational cultures may implicitly devalue breadth, viewing polymathic curiosity as dilettanteism rather than strategic advantage. However, some organizations are beginning to recognize these limitations. Companies pursuing advanced manufacturing transformation increasingly seek leaders who can bridge engineering and social science perspectives for roles overseeing human-robot collaboration systems. Healthcare systems implementing AI-augmented diagnostics prioritize leaders who understand both algorithmic capabilities and clinical workflows. Automotive manufacturers developing sustainable mobility ecosystems recruit executives with experience spanning manufacturing, software, urban planning, and environmental science. This emerging shift reflects a broader recognition that Industry 5.0 complexity demands cognitive diversity at leadership levels, not as a social objective but as a functional requirement for navigating multidimensional transformation. Organizational and individual consequences of leadership approach. Organizational performance impacts the leadership approach organizations adopt for Industry 5.0 transformation produces consequences across multiple performance dimensions. Research examining innovation outcomes in complex environments finds that teams with diverse knowledge bases and varied expertise generate more novel solutions and navigate uncertainty more effectively compared to homogeneous specialist teams. Taylor and Grieve. 2006. The effect appears particularly pronounced for innovations requiring integration across technical, market, and regulatory domains, precisely the challenge Industry 5.0 presents. Organizations whose leadership teams can recognize patterns across multiple domains appear better positioned to identify emerging opportunities and threats that specialists might miss. The capacity to connect insights from disparate fields may enable more creative strategic responses to complex challenges. Sustainability integration appears to require genuine understanding of both business operations and ecological systems, rather than treating sustainability as a separate functional domain. Organizations whose leaders possess substantive knowledge spanning business and environmental considerations tend to develop more systemic approaches to sustainability rather than superficial compliance measures. The risk consequences of leadership approaches merit particular attention. Organizations led by leaders who can identify connections between technical, social, and environmental factors may demonstrate greater resilience to systemic disruptions. Leaders with broader knowledge networks potentially adapt more rapidly by identifying alternative approaches that specialists focused on single domains might overlook. Conversely, leadership gaps in polymathic capability can produce identifiable failure patterns. Technology implementations that ignore human factors often generate worker resistance and productivity losses. Sustainability initiatives divorced from business model innovation may achieve superficial compliance without substantive impact. AI systems deployed without ethical framework integration can produce bias incidents that damage reputation and market position. Individual and societal impacts. Leadership approach affects not only organizational outcomes but workforce experiences and broader societal consequences. Organizations led by leaders who understand both technological capabilities and worker well-being may create substantively different employment experiences. Research suggests that workplace technology approaches emphasizing worker skill enhancement and meaningful human contribution tend to achieve higher job satisfaction and greater worker trust compared to automation-centric approaches that treat humans as residual components. Parker and Grota. 2022. The distribution of Industry 5.0's benefits and costs across society depends substantially on leadership values and knowledge. Leaders who understand labor economics alongside manufacturing technology may make different workforce transition decisions than pure technologists. Organizations led by executives with both technical and social science perspectives may invest more systematically in reskilling programs and demonstrate greater commitment to employment continuity during technological transitions. Environmental and community impacts similarly reflect leadership knowledge patterns. Leaders who genuinely understand ecological systems may design production approaches that regenerate rather than merely sustain. Companies known for environmental leadership often feature executives with backgrounds spanning technical and environmental domains, enabling innovations that combine technical advancement with systemic environmental thinking. Conversely, narrow leadership perspectives can produce externalization of social and environmental costs. Organizations led by executives focused exclusively on financial and technical metrics may systematically underinvest in worker transitions, community impacts, and environmental restoration, not because of malice but because these dimensions remain outside their cognitive frameworks and evaluation systems. The aggregate societal consequence is significant. If Industry 5.0 transformation proceeds under predominantly specialist leadership, it risks reproducing earlier industrial revolution's pattern of concentrated benefits and distributed costs, productivity gains captured by capital owners while workers face displacement. Communities experience disruption, and environmental degradation continues. Polymathic leadership offers an alternative pathway, one where technological advancement, human flourishing, and environmental regeneration become integrated rather than competing objectives. Evidence-based organizational responses. Organizations seeking to cultivate polymathic leadership for Industry 5.0 can draw on research evidence identifying effective developmental approaches, structural interventions, and cultural practices. The following sections examine specific, evidence-based responses organized by intervention type. Structured cross-disciplinary learning programs. Formal learning experiences designed to broaden leadership knowledge across relevant domains represent a foundational intervention. Research on executive development effectiveness indicates that programs integrating multiple knowledge domains produce gains in integrative thinking compared to single-domain programs. Boyman-Siller, 2010. Effective programs share several design principles. Content integration across domains, rather than sequential modules where executives study technology. Then sustainability, then organizational design in isolation. Effective programs interweave concepts throughout. Leaders might examine a manufacturing challenge simultaneously through engineering, worker experience, environmental impact, and business model lenses. Building capacity for multi-perspective analysis. Problem-based learning structures. Abstract knowledge proves less transferable than knowledge acquired while solving authentic problems. Programs that engage leaders with actual Industry 5.0 challenges. Designing human-AI collaboration systems. Developing circular production models, creating sustainable supply networks, generate deeper learning and practical capability. Diverse faculty and peer groups. Learning alongside and from individuals with different disciplinary backgrounds accelerates polymathic development. Programs that deliberately construct cohorts spanning engineering, social science, business, and sustainability backgrounds create environments where cross-disciplinary thinking becomes natural rather than exceptional. Several organizations have implemented structured cross-disciplinary programs. Siemens has developed leadership academies where senior leaders rotate through immersive experiences spanning data science, human factors engineering, sustainability science, and business model innovation. Participants work in interdisciplinary teams on transformation challenges, learning both content and collaborative integration skills. Such programs aim to build both knowledge and the capacity to synthesize across domains. Novo Nordisk, recognizing that biopharmaceutical innovation increasingly requires integration of molecular biology, Digital health, patient experience design, and healthcare economics has created systems leadership programs. These combine formal learning modules with cross-functional project assignments where technical leaders work in commercial roles and business leaders engage in research functions. Effective learning programs also incorporate reflective practice components, structured opportunities for leaders to examine their thinking patterns, identify knowledge gaps, and develop personal learning strategies. Research on adult learning demonstrates that metacognitive awareness, understanding how one thinks and learns, significantly enhances knowledge integration across domains. Schroer and Dennison. 1994. Career architecture supporting cross-domain development. Organizational career systems powerfully shape leadership capabilities by determining what experiences individuals accumulate over decades of professional development. Traditional functional career paths produce specialist expertise. Polymathic capability requires deliberately designed cross-domain experiences. Rotational assignments across functions and domains. Research on leadership development demonstrates that substantive exposure to multiple organizational functions produces broader cognitive frameworks and more integrative decision-making. McCall. 2010. Effective rotations involve genuine role responsibility rather than observational tours, typically lasting sufficient time to develop authentic competence. Dual-track advancement systems. Traditional hierarchies force a choice between specialist depth and generalist breadth. Progressive organizations create advancement pathways valuing both. Technical fellows can achieve status and compensation equivalent to executives while remaining in specialized roles, while polymathic leaders advance through breadth and integration rather than functional mastery alone. Boundary-spanning role creation. Some organizations establish positions explicitly designed to bridge domains. Chief Transformation Officers, Chief Sustainability Officers, and similar roles require integration across traditionally separate functions. When these positions carry genuine authority rather than only coordinating responsibility, they develop polymathic leadership capability. ABB, the robotics and automation company, has redesigned aspects of its leadership pipeline to support broader development. High potential leaders may progress through sequences including technical roles, commercial functions, and capability building assignments. Some companies are beginning to evaluate senior candidates on breadth across technical, commercial, and human dimensions rather than functional expertise alone. Unilever has implemented leadership development programs specifically designed to develop cross-domain fluency for sustainable business transformation. Participants rotate through supply chain operations, brand management, sustainability initiatives, and digital transformation projects. The program deliberately pairs technical and non-technical backgrounds. Engineers work in marketing. Business graduates engage in operations and sustainability projects. Performance evaluation systems. What organizations measure and reward shapes behavior profoundly. Organizations cultivating polymathic leadership increasingly incorporate learning agility, cross-domain collaboration, and integrative thinking into performance criteria alongside traditional functional metrics. Leaders earn recognition not only for technical accomplishments but for knowledge acquisition in unfamiliar domains and successful integration across specialties. Collaborative structures enabling cross-disciplinary integration. Organizational structures significantly influence whether specialized knowledge remains siloed or becomes integrated. Research on innovation in complex domains demonstrates that team structures bringing together diverse expertise can generate more creative solutions than homogeneous expert groups, particularly when designed with attention to integration mechanisms. Harvey. 2014. Cross-functional transformation teams, rather than assigning Industry 5.0 initiatives to single departments, effective organizations establish teams combining technical specialists, human factors experts, sustainability professionals, and business strategists. These teams function most effectively when given genuine decision authority and held accountable for integrated outcomes rather than separate technical, social, and environmental metrics. Design thinking and systems mapping methodologies, structured approaches that make diverse perspectives visible and create shared understanding across specialists facilitate integration. Design thinking's emphasis on multi-stakeholder needs and systems mapping's visualization of interconnections both help polymathic leaders and specialists communicate effectively. Regular cross-functional forums and communities, formal mechanisms for specialists from different domains to share challenges, solutions and insights build organizational capacity for cross-domain learning. These work best when focused on authentic problems rather than abstract knowledge sharing. Schneider Electric has established cross-functional teams addressing complex sustainability and Industry 5.0 challenges. These teams include engineers, data scientists, social scientists, environmental specialists, and business representatives working together on problems like sustainable building automation or circular economy business models. The teams use structured integration methodologies including systems mapping and stakeholder analysis to weave together technical, human, environmental, and commercial considerations. In healthcare, Kaiser Permanente has created care redesign initiatives bringing together clinicians, software engineers, user experience designers, operations specialists, and patients to co-design technology-enabled care models. This structure reflects recognition that effective healthcare innovation requires integration of medical knowledge, technical capabilities, human factors understanding, and operational realities. Innovation labs and experimental spaces, organizations cultivating polymathic leadership often establish dedicated environments where leaders can experiment with new technologies, methods, and approaches outside normal operational pressures. These labs function as learning environments where leaders from different backgrounds can explore emerging capabilities together, building shared understanding across domains. Knowledge infrastructure and sense-making tools. Polymathic leadership requires access to knowledge across domains and tools for making sense of complex, multidimensional information. Organizations can invest in infrastructure supporting cross-domain learning and integration. Curated learning resources spanning relevant domains, digital libraries, expert databases, and learning platforms that make high-quality content from multiple fields accessible help leaders efficiently acquire knowledge outside their primary expertise. Effectiveness increases when these resources include both foundational concepts and applied industry examples. Visualization and modeling tools, technologies that help leaders see connections across domains support polymathic thinking. System dynamics modeling software, network visualization tools, and integrated performance dashboards that display technical, social, environmental, and financial metrics simultaneously help leaders recognize interdependencies and develop integrative solutions. Access to diverse expertise networks, platforms connecting leaders with specialists across domains, internal experts, academic collaborators, industry communities, enable rapid learning and consultation. Research indicates that leaders with broader professional networks generate more innovative solutions by accessing diverse knowledge. Burt. 2004. Philips, in its transformation from product manufacturer to health technology and services company, has invested in knowledge infrastructure supporting cross-domain leadership. The company has created learning platforms providing content spanning medical science, healthcare delivery systems, data science, human factors engineering, and health economics, disciplines leaders must understand to navigate digital health innovation. Such platforms may include case studies showing how these domains intersect in practice and connection mechanisms to internal and external experts. Regular exposure to emerging knowledge. Organizations cultivating polymathic capabilities often establish practices ensuring leaders encounter new developments across relevant fields. This might include regular briefings on emerging technologies, attendance at cross-disciplinary conferences, engagement with academic research, and structured horizon scanning across technical, social, environmental, and market domains. Recruitment and selection emphasizing cognitive diversity. Organizations serious about polymathic leadership increasingly recognize that development programs alone prove insufficient. They must also recruit individuals with polymathic potential and demonstrated cross-domain capability. Expanded candidate profiles, rather than recruiting exclusively from traditional pathways, engineering for technical roles. MBA programs for business positions. Organizations can seek candidates with diverse educational backgrounds and career experiences. Engineers with humanities graduate degrees, scientists with business experience, designers with technical capabilities, all bring valuable polymathic potential. Assessment of learning agility and integrative thinking. Selection processes can evaluate candidates' demonstrated capacity to learn new domains and connect across fields. This might include examining past experiences where candidates navigated unfamiliar territory. Assessments measuring cognitive flexibility and pattern recognition. Or interviews exploring how candidates approach multidimensional problems. Valuing non-traditional experiences, career paths including diverse roles. Industries or functional experiences can indicate polymathic capability rather than lack of focus. Selection criteria that recognize lateral moves and domain-crossing experiences as developmental assets rather than liabilities identify polymathic potential. Tesla, while known for technical excellence, has sought leadership with relatively broad backgrounds. The company looks for engineers who understand manufacturing, designers who comprehend software, business leaders with technical depth. This reflects recognition that sustainable transportation transformation requires integration of battery technology, vehicle engineering, manufacturing innovation, software development, energy systems, and business model design. IKEA, pursuing circular economy transformation, has increasingly recruited leaders with combinations of retail operations, sustainability knowledge, materials understanding, and consumer behavior expertise. The company recognizes that circular business models require simultaneous innovation in product design, reverse logistics, customer behavior, and business economics, domains that must be integrated rather than optimized separately. Building long-term polymathic organizational capacity while specific interventions help organizations respond to immediate Industry 5.0 leadership needs. Sustaining polymathic capability over time requires deeper institutional changes affecting culture, structures, and systems. This section examines forward-looking frameworks for embedding polymathic thinking into organizational DNA. Cultivating organizational learning culture and psychological safety. Polymathic leadership thrives in environments that encourage intellectual curiosity, reward learning, and tolerate the uncertainty inherent in venturing beyond established expertise. Research on organizational learning demonstrates that psychological safety, the belief that one can take interpersonal risks including admitting knowledge gaps and asking questions, proves essential for learning and adaptation. Edmondson, 1999. Organizations can cultivate cultures supporting polymathic development through several practices. Leadership modeling, when senior leaders visibly engage in learning outside their expertise, admit uncertainty and demonstrate curiosity across domains. They signal that polymathic behavior is valued rather than career-limiting. Recognition systems, celebrating examples of successful integration across domains and honoring learning achievements alongside task accomplishments reinforces polymathic values. Failure tolerance. Polymathic exploration inevitably involves ventures into unfamiliar territory where mistakes occur. Cultures that treat such failures as learning opportunities rather than career setbacks enable broader experimentation. Structured reflection practices, regular team and individual practices for examining learning, identifying knowledge gaps, and sharing insights across domains help embed continuous learning into organizational routines. After-action reviews following major initiatives might explicitly examine what technical, human, environmental, and business insights emerged and how well they were integrated. Diverse perspectives in decision-making, deliberate inclusion of different disciplinary viewpoints in strategic discussions signals that cross-domain integration matters. When technology decisions routinely include human factors perspectives. When sustainability initiatives incorporate business model thinking. When organizational design considers technical implications. Polymathic thinking becomes normalized. Organizations like Patagonia exemplify strong learning cultures. Leadership regularly engages stakeholders in discussions spanning environmental science, manufacturing innovation, fair labor practices, and business strategy, treating these as integrated rather than separate concerns. The company encourages experimentation with new materials, production methods, and business models. This culture has enabled innovations like recycled materials development and rental business models that require integration across materials science, manufacturing engineering, consumer psychology, and business economics. Distributed leadership networks and knowledge integration. Traditional hierarchical models concentrate strategic decision-making at senior levels. But Industry 5.0 complexity often exceeds any individual's or small team's knowledge capacity. Organizations are increasingly experimenting with distributed leadership networks where strategic thinking and decision-making occur across multiple levels and nodes, with formal leaders serving as integrators and enablers rather than sole decision-makers. Communities of practice spanning domains, self-organizing groups where practitioners from different specialties explore common challenges can serve as knowledge integration mechanisms. A community focused on human-AI collaboration might include data scientists, industrial engineers, organizational psychologists, and frontline workers, creating organic opportunities for cross-domain learning and solution development. Federated decision structures, rather than centralizing all Industry 5.0 decisions, organizations can delegate domain-specific authority while creating integration mechanisms to ensure coherence. Technical teams might lead AI implementation decisions. HR teams lead workforce development, sustainability teams lead environmental initiatives, with cross-functional councils ensuring alignment and integration. Network leadership competencies. In distributed models, leaders require different capabilities than traditional hierarchical leadership. They must excel at facilitation, translation across specialties, pattern recognition across distributed activities, and weaving together diverse initiatives into coherent strategies. These are inherently polymathic capabilities, requiring understanding of multiple domains to recognize connections and integration opportunities. W. L. Gore, the materials science company known for products like Gore-Tex, operates with relatively flat structures and distributed leadership patterns. Technical, commercial, and operations expertise exists throughout the organization, with leadership emerging based on knowledge and influence as well as position. This structure may enable more rapid integration of materials science innovations with market insights and manufacturing capabilities because relevant knowledge holders can connect more directly. Purpose-driven integration and stakeholder orientation. Polymathic leadership becomes more than intellectual exercise when anchored in clear purpose that inherently requires cross-domain integration. Industry 5.0's explicit emphasis on human centricity, sustainability, and resilience provides such purpose, but only if organizations embrace it authentically rather than rhetorically. Stakeholder governance models, organizations that acknowledge accountability to multiple stakeholders, employees, customers, communities, environment, investors, create imperatives for polymathic thinking. Serving these diverse interests requires integration across financial, social, environmental, and human dimensions. Mission statements requiring cross-domain integration, when organizational purpose explicitly encompasses technological advancement and human flourishing and environmental regeneration. Leadership cannot succeed through technical or business excellence alone. Purpose statements requiring demonstrable progress across multiple value dimensions create demand for polymathic capability. Impact measurement across domains. What organizations measure shapes leadership attention. Integrated measurement frameworks that track technical performance. Worker well-being, environmental footprint, and financial results simultaneously, treating all as essential rather than trading off among them, require leaders to develop fluency across domains and seek solutions that advance multiple objectives. Interface. The carpet manufacturer adopted a mission of achieving sustainable manufacturing, explicitly requiring integration of materials science, manufacturing innovation, circular economy thinking, and business model transformation. This purpose-driven integration imperative led leadership to develop capabilities spanning chemistry, industrial ecology, supply chain design, and customer relationship models. The company has worked toward carbon-negative manufacturing while maintaining financial performance, demonstrating that purpose requiring cross-domain integration can drive polymathic leadership development. Continuous learning systems and adaptation mechanisms. Industry 5.0 technologies and societal contexts evolve rapidly. Polymathic leadership must similarly evolve. Organizations need systems ensuring leadership capabilities continuously expand to address emerging domains and challenges. Horizon scanning across domains, systematic monitoring of developments in relevant technical, social, environmental, and market domains helps organizations identify emerging knowledge areas leaders should develop. This might include tracking AI capability evolution, sustainability science advances, workforce demographic shifts, and regulatory developments, treating all as relevant to strategic leadership. Adaptive learning pathways, rather than fixed leadership development programs. Organizations can create adaptive systems that respond to emerging needs. As quantum computing or synthetic biology or new organizational models become relevant, learning resources and experiences can incorporate these domains. Research partnerships and academic engagement. Ongoing relationships with universities and research institutions provide organizational access to emerging knowledge across fields. Leaders who regularly engage with academic research across relevant domains maintain currency and develop capacity to integrate new developments. Experimentation portfolios, organizations that systematically experiment with emerging technologies, organizational models, and sustainability practices create learning opportunities for leaders. Structured programs where leaders sponsor, participate in, and learn from diverse experiments build practical polymathic capability. Ericsson, the telecommunications company, has established research functions that deliberately span hardware engineering, software architecture, network systems, and related domains, rather than segregating these into completely separate labs. The company creates integration opportunities where leaders and researchers from different domains collaborate on emerging challenges. This structure helps ensure leadership remains current across evolving technical domains while developing integrative capability. Conclusion. Industry 5.0 represents more than technological evolution. It embodies a fundamental reconception of industrial production's purpose and methods, placing human capability, environmental regeneration, and societal resilience at the center rather than periphery. Realizing this vision demands leadership that transcends specialist expertise to embrace polymathic thinking, the capacity to learn across disciplines, recognize patterns spanning domains, and synthesize technical, human, environmental, and business considerations into coherent strategies. The evidence examined throughout this article demonstrates several key insights. First, polymathic leadership appears to offer advantages in innovation performance, implementation effectiveness, and organizational resilience, benefits particularly relevant for complex, multidimensional challenges characteristic of Industry 5.0. Second, polymathic capability can be systematically cultivated through deliberate organizational interventions including structured learning programs, career architectures supporting cross-domain development, collaborative structures enabling integration, and knowledge infrastructure supporting sense-making. Third, organizations across industries, from Siemens and ABB in manufacturing to Kaiser Permanente in healthcare to Patagonia in consumer products, have demonstrated approaches to polymathic leadership that appear to yield both competitive advantage and stakeholder benefits. For organizational leaders, several actionable implications emerge. Audit current leadership capabilities against Industry 5.0's multidimensional requirements, identifying gaps in cross-domain knowledge and integrative thinking capacity. Design development experiences that deliberately build breadth across technical, human, environmental, and business domains rather than deepening single-domain expertise. Exclusively create structures and processes that bring diverse specialties together in genuine collaboration rather than sequential handoffs. Recognize and reward learning agility, cross-domain integration, and polymathic thinking alongside traditional functional excellence. Recruit for cognitive diversity, valuing candidates with demonstrated capacity to bridge domains and learn across specialties. Anchor polymathic development in authentic purpose requiring integration, human-centric technology, sustainable production, resilient systems, rather than treating it as abstract capability. The transition to Industry 5.0 will unfold over years and decades, presenting continuously evolving challenges as technologies advance, societal values shift, and environmental imperatives intensify. Leadership adequate for this journey must itself embody continuous learning, intellectual humility, and integrative ambition. Polymathic leadership, characterized by breadth across domains, depth in synthesis, and commitment to multidimensional value creation, offers a pathway toward industrial transformation that advances technological capability while enhancing human flourishing and environmental regeneration. The industrial revolutions of the past succeeded by optimizing specific dimensions: mechanization, electrification, automation, digitization. Industry 5.0's promise lies in integration, harmonizing technology and humanity, efficiency and sustainability, productivity and purpose. Realizing this promise requires leaders whose cognitive architecture mirrors this integration, polymathic minds capable of holding technological sophistication and human wisdom, business acumen and environmental consciousness, specialist depth and generalist breadth in creative tension, generating innovations that advance multiple objectives simultaneously. The organizations that cultivate such leadership will shape not only their competitive futures but the nature of industrial civilization itself.